Good job. Time for the next step in our process, distinguish user prompts. In Linux, the command prompt, the text provides valuable information about your current status. In the LabX environment, knowing how to read this prompt is essential. Beginners often focus only on a command. They want to type next. Experienced operators also read the prompt first. A quick glance helps answer questions like, am I a normal user administrator? And am I in the directory? I think, am I in? For standard users, the prompt looks like LabX project, LabX current username, your current directory, home LabX project, the symbol indicating standard user, and the root user administrator prompt changes to the root hostname. You do not need to understand every symbol yet. For now, treat the prompt as status bar that gives you context before every command. The $sign, $sign indicates a standard user. This is the standard safest mode, preventing accidental system damage. $sign indicates the root user, super user. The root user has full administrative control. The idea of a powerful administrator account comes from Unix tradition. Linux inherits that model. The root is special because it refers to the account with authority over the whole system. That is convenient for maintenance, but dangerous if used carelessly, because a root command can affect nearly any file or setting. Let's observe this difference in practice. First, look at your current prompt. It should end with a $sign, yes. Now switch to the root user temporary using the sudo command. It stands for super user do and allows you to execute commands with administrative privilege. In many modern Linux systems, administrators are encouraged to use sudo instead of logging in as a root all the time. This keeps normal work separated from administrative work and makes elevate actions more deliberate. Sudo I. Observe the prompt, change it now with an hashtag. The hostname part will be a random string of characters in your environment. It is best practice to work as a standard user unless you specifically need administrative powers. Type exit to return to your standard user. You should see the prompt again. Okay, understand the terminal. So imagine the difference between a restaurant menu and talking to a chef. A graphical interface is like a picture menu, use it but limited to what's shown. The terminal is like talking directly to the chef. You can ask for exactly what you want even if it's not on the menu. The terminal is your direct line to the computer. It may look like a simple black screen with text, but it's a superpower that gives you complete control of the system. There is also a small distinction worth knowing early. The terminal is the text window you interact with. The shell is the program inside the windows that reads your commands, asks Linux to run them. You do not need to master the shell yet. Just remember that something is listening to what you type and turning into an action. There's a bit of history behind a word terminal. Long before modern laptops, people often interacted with large shared computers through physical text devices called terminals. They were essentially keyboards and screens connected to another machine. Modern terminal windows imitate the old style of interaction, which is why command line culture still uses the same vocabulary. Your first conversation. In the lab's environment, the terminal is already open for you. The blinking cursor indicates that the computer is waiting for your input. It is essentially asking, what should I do next? Let's start with a fundamental question. Who am I? In Linux, we use specific commands to communicate to ask, who am I? Use the command who am I, click on the terminal window to ensure it is active. Type who am I and press enter. Okay, you see an output similar to this. Congratulations, you have successfully communicated with the computer. Reply that your current username is Lab or Labex, whatever you pronounce this. This seems like a tiny result, but it establish an important Linux habit before doing anything else. Confirm who you are and what environment you are working in. That habit matters because Linux and Unix were designed as multi-user systems from the beginning. The system expected different people to log in, work, and have different permissions on the same machine. Inspect result, continue. Perfect. So now we go to step 2. Distinguish user prompts. In Linux, the command prompt text before the cursor provides valuable information about your current status in the LabX environment. Knowing how to read this prompt is essential. Beginners often focus only on the command they want to type next. Experienced operators also read the prompt first. That a quick glance, we already read this. Continue. Oops. So basically we have to do this. All right. So you want us to do a sudo I. Okay. Sudo root. Observer prompt changes now to, yeah, correct. And the host name part will be a random string in your environment. It's the host name. It is best practice to work as a standard. And then we can do reinspect maybe. Okay, continue. Okay, check current location. You ask who am I, now it's asks where am I. To find your exact location in the file system, use the PWD, which stands for print working directory. Print working directory. The phrase working directory simply means the folder your shell is currently standing in. Many Linux commands behave differently depending on where you are, so your identity and your location are the two pieces of context you should learn to check early and often. The word path is also important. A path is the written address of location in the file system. Linux uses the / to separate each level in that address. You will see this pattern everywhere, from directories to configuration files to log locations. Type the following command. So we're the root right here. If we do exit, we're here. So you will see the output. This confirms you're inside the project folder, which is located in the LabX directory. Perfect. Check system host name. Just as every user has a name, every computer and a network has a host name. This helps identify the machine, which is especially important when checking which server are currently logged in. This is another real-world safety habit. In operations work, engineers often connect to many machines that look similar. Running the right command on the wrong host can cause confusion and outage, so checking the host name is simple but important. A host name is the human usable name of a machine inside a system or network. It may be something friendly like W01 or something automatically generated. Later in your Linux journey, you will see host names appear in prompts, logs, SSH sessions, and monitoring dashboards. In this step, you will find out the name of your Linux environment. Type the following command: hostname, so that's my host name. The output will display it's a unique identifier similar to this. Knowing the host name is essential when managing multiple servers. Congratulations, you have succeeded completely. Terminal access, prompt, identify, location, system. The basic commands are the foundation for the Linux operation. Perfect. We're gonna load. Welcome. In the previous lab, you learned how to open the terminal and verify your identity. Now it's time to understand the language of the interface itself. When you open a terminal, the system provides a wealth of information at a glance. The text that appears before your cursor is called a prompt. It acts like a dashboard telling you who is logged in, where you are, and a system status. This matters because terminal work is highly contextual. The same command can produce different results depending on which user you are, which directory you are in, and what shell is interpreting your command. The prompt helps you collect that context before you act. In classic Unix culture, the prompt became important because users often share work quickly, remotely, and sometimes on shared systems. A good prompt saves time and prevents mistakes. That is why many experienced engineers customize their prompts heavy later in their careers. In this lab, you will learn decode the prompt, understand the meaning of LabX, speak to the system, use the echo command to print text and variable values. Keep it tidy, use the clear command. Perfect. So when we're giving me the same thing, why are we back to the same? I understand. Should be going to the next one. It's weird. We're like kind of redoing the same thing. I don't get it. Okay, who am I? Is he asking me to redo this? Okay, print text with echo. Now that we can read the prompt, let's try sending a message to the system. We'll use the echo command. The echo command is one of the simplest and most useful commands in Linux. Its job is to take text you provide and print it back to the screen. Standard output. It is often used in the scripts to display status, updates, or instructions. Even though echo looks simple, it introduces a bigger idea. Not every command changes the system. Some commands simply display information. Learning this early helps you separate read-only commands from commands that actually modify files or settings. It also hints at classic Unix design style. Many commands are small and focused instead of one giant program doing everything. Unix Linux often provides simple tools that each do a narrow job well. Basic usage. Let's start with a basic greeting. Type the following: echo hello world. Okay, so you should see hello world print back to you. It is the best practice to always wrap your text in double quotes. This keeps your text safe from being misinterpreted by the shell, particularly if you contain special characters using variables. The system uses variables to store information like label boxes. For example, there is a box labeled users that contains your current username. These variables are part of your shell environment. They store context that programs can reuse, such as your username, home directory, language, or terminal type. You will work with environment variables more deeply in a later module. For now, it is enough to see that shell substitute store values in your commands. When a shell replaces user with its store value before running the command, that process is called expansion. You do not need to memorize the term yet, but the behavior is important. The shell can transform parts of your commands before the program actually receives it. To see what's inside a variable, use the sign followed by the variable name. Let's ask echo to print the contents of the user variable. So this is very important. The system uses variables to store information like label boxes. For example, there's a box labeled users that contains the current user name. Okay, so if we do echo I am logged in as user. I'm logged as LabX. This system replaces LabX. Okay, we got it. So you're doing a great job. Clear the screen. So we learned that already. Clear does not erase your work or remove command history. It only improves readability by redrawing the screen. That distinction is important because beginners sometimes worry they have lost their previous commands after clearing the terminal. It is a good reminder that the terminal is both a working environment and a reading environment. As command outputs grows longer in later modules, managing what you see on screen becomes part of working comfortably. First, let's fill up the screen with a few more lines. Now make it all disappear by clearing. Control L, I did that. Perfect. Congratulations, you have successfully completed this lab. Let's recap. You have learned reading prompt. You can now decode to understand the user's location and privilege echoing. You learn to use the echo to print messages and display variable values like user. Clearing the screen, you know how to keep your workplace tidied, clear. Let's continue. Okay, introduction. Welcome back. Now that you understand the terminal structure, so we have 60 minutes each time. This is perfect. I thought it was gonna block me. We'll see. Now you understand the terminal using the execute command. Think of the terminal as obedient assistant. You give it a command and it does exactly what you ask, provided you ask correctly. The last part is important. The terminal is precise rather than forgiving. If your command is correct, Linux will do exactly what you requested. If your command is misspelled or incomplete, Linux usually will not guess your intention. Learning to read both successful output and errors messages is therefore part of learning Linux itself. There's also an important conceptual shift here. A command usually not magic. In many cases, you are simply launching a small program that performs one job and then exits. This style comes from Unix, where tools were intentionally kept small and composable. In this lab, you will ask for information, execute the date, command to check the system time, make mistakes, intentionally run an unassisted command to understand error messages. Say goodbye, use the exit command to properly close your session. This simple demonstrate the core cycle of Unix Linux. Input, execution, output. So check system time. Let's start with simple task, asking the computer for the current time. In Linux, we use the date command for this. This is a good first example because it is safe, simple, and useful. Time appears in logs, schedules, backups, and automation. Even basic command like date connects to real operation work. Type date into the terminal and press enter. Okay, you will see the output. This output shows the current day, month, time, and zone. The time zone is part of important real system work. Logs, schedules, tasks, backups, distribute system all depend on time being interpreted correctly. Two servers can show the same clock time differently if their time zones differ. What happened? Input, you type the name of the program. Execution, the system found the date, program, and ran it. Output, the program printed the time, the screen. Ready, the prompt reappeared, indicating system is ready for next command. This is a standard workflow for nearly all Linux commands. Many beginners expect every command to behave like an app with buttons and windows in a terminal. The normal pattern is simpler: run a program, read the output, then return the prompt. Understand errors. Now let's see what happens when things go wrong. Don't worry, you cannot break the computer by typing incorrect commands. Errors are not interruption to learning. They are part of learning. Good Linux users are not people who never see errors. They are people who can read an error carefully and use it as a clue. We'll intentionally ask the computer to run a command that doesn't exist. Type foobar. Command does not exist. Decoding the error. This is a very common message. It breaks down as the shell, your assistant speaking. Command not found. The core program is search for the program but couldn't find it. The command you tried to run. Behind the scenes, the shell usually searches through a list of directories where executable programs are expected to live. If it can't find a matching program name in those places, you get a command not found message later. When you learn about environment variables, you will meet the path variable that controls the search behavior. Why this is important? When you encounter this error, it usually means typo. You misspelled the command, type in date instead of date, missing software, the program isn't installed. So when you see command not found, always check your spelling first. Later you will see other kind of errors such as a permission denied, no such file, directory. Each message points to a different category. Close the session. You have successfully executed a command and analyze error. Now it's time to close the session. When working on remote service, it's good to practice to log out properly when finished. This is partially about security, partly about clarity. Logging out cleanly reduces the chances of leaving an administrative session open, confusing yourself about which terminal is still alive. On share a production system, this habit is more than neatness. It's part of operational discipline. Good administrators keep track of when they are connected to which machine with what level of privilege. Type exit. What experts do: this would close the windows, disconnect the session. Congratulations, you have completed the basic checkup Linux environment. In this lab you learn how to run a valid command and how to close. Okay. Current working directory. Okay, imagine Linux file system is a giant office building with thousands of rooms, directories. When you use the terminal, you are always standing inside one specific room. This is your current working directory. This idea sounds simple, but it's one of the most important concepts in the entire course. Many commands operate on a current place unless you tell them otherwise. If you do not understand where you are, later commands can feel unpredictable. Linux also organizes data in a very unique way. Instead of separate drive letters like C or D, it presents one unified directory tree that starts at the root. That design is part of what path and navigation matters so much in Linux. Just like in a real building, you want to find a file or run a program, you need to know where am I right now? How do I get to where I want to go? In this lab, you will learn the art of navigation, find your location, move to the new room, verify your move by checking your surroundings. Okay, what happened? We're done. Free plan limited to 3 VM launches per day. So we are done. What happened with the Pro? Free 3. It's $99 a year. So it's a one shot, this one. Yeah, it's $99 a year. Oh well, we're moving quick and fast. We'll have to find a new solution once more.